Hello everyone. In this video, I'll show how to combine latest weather data with AI and create something amazing in Azure AI Studio. In Azure AI Studio prompt flow, I'm going to use the external weather API to get the latest weather information and then feed that information into our LLM so that a human-like response can be provided. So now let's check the step-by-step implementation of the external weather API in the lab. I'm logged into Azure portal now, and let's go to Azure AI Studio first. And in the Azure AI Studio, I'll create a new hub. Let's create the new resource group RG Hub. I'll name it as Shalender Hub 01. And automatically, once you create the hub, the Azure AI services based model will be connected with it. It's creating a new connection. And for saving the data in the hub, you need storage account. So a new storage account will be created. If you have an existing storage account, then you can use that one. And for storing the credentials, I'll use the key vault. So there is an option of Microsoft Manage, which is in preview, but I'll use the key vault. I'll leave everything default. For the network isolation, it's recommended to use private, but in this case, I'll use the public because this is just a lab. No encryption to be required, and it'll use the system assigned managed identity. And the storage account access will be based on the credential based access. So review and create and create. The deployment has started now, and I'll pause the video and we'll be back once the hub is deployed. Deployment is complete now. Let's go to the resource. So this is Azure AI Hub. Instead, let's go to the resource group and see the different resources which are created. So there are 4 resources which are created. First one is the storage account, which is used for saving the data in the hub. Another one is the key vault, where the credentials are saved for the storage account. Then the AI Hub itself, and Azure AI services, which is connected to the hub. So let's go to Azure AI Hub and launch Azure AI Studio. However, it's being renamed to Azure AI Foundry now, as you can see here. But Microsoft hasn't made the changes everywhere. So in the Azure portal, it's still showing as Azure AI Studio, but when you launch Azure AI Studio, it shows Azure AI Foundry. And as soon as you create a hub, you need to create a project to work in it. So let's create a project 01. Create this project. Project is created now. Now on the left side, as you can see, the different models, AI service, playground, and all these features as well as the services you can use within the Azure AI Foundry. So the plan in this project is to use the prompt flow, where in the input we'll provide the name of the location. Then we'll feed that input into the Python code, which will pull the information from the API. So for the external API, we'll be using the weather API, which is OpenWeatherWork. So openweathermap.org. So you can create a free account here. If you'll log in and go to the pricing, first you have to create account, go to the pricing, and there is an option of free account. So what you have to do is get the API key. I am already signed in, so I can go to my API keys and I can find my key here. And don't worry about the key. I'll just remove or regenerate this key once this video is over. So I'll use this weather key. There are some limitations which you can find here. If we'll go on the pricing again. So it provides the forecast for 5 days, current weather, it provides the basic weather map, air pollution, and the weather widgets. And there is an uptime for 95%. However, if you'll pay as a professional or enterprise, you will get better uptime, 99.9%. But in this lab, I'm just going to use the free API. So let's go back to our Azure AI Studio. And once we'll have the information from the weather, then we need to feed that information to the LLM so that it can provide a human type response. And for that LLM, I'm going to use the GPT mini model. So let's go to the models. Right now, no model is deployed. So let's deploy a new base model. And there are multiple options available. I'll just use the GPT-4o mini. because I'm not going to use the intelligence of the LLM. I'm just going to get the details from weather API and then pass this information into LLM, which will just rephrase it and provide it in a human readable response. So confirm. It's getting deployed in the France Central and deploy. So our GPT-4o mini model is deployed. We can open in the playground and test it. However, we'll just directly use in the prompt flow and see how it provides the response. So let's go to the prompt flow, create a standard flow, create. When you create a new project, and first time when you create a standard flow, 95% chances are that it will fail. So let's see how it works this time. You have to just refresh your screen and try again and it'll work. See, as I got the error, this is mostly happens when you create a new project. So what you have to do is cancel it and try again, and mostly it works. Just provide the name and create, and this time it should create. Perfect, it's created now. And now we have a flow already created. However, we want to use it by our own, so let's delete it. Delete the LLM step, delete the Python step, though we are going to use both of these steps, but let's delete them. And if you want to use the more tools, which in this case we are not going to, but you need to first start the compute session. So anyways, because we need to validate the code and everything, so for that we need to start the compute session. So let's click on start compute session. For me it takes around 3 to 5 minutes. However, it informs that it takes around 1 to 3, but usually takes around 3 to 5 minutes, as you can see here. I'll pause the video and we'll be back once this is created, and then we'll start with the next steps. Compute session has started now, as you can see here. Standard E4S v3 virtual machine is created. So now let's start with the Python function. Let's name this as weather API add, and I'll provide the Python code here. So in this Python code, we need the location and we'll provide the API key where the units will be metric. So based on that, it will provide us the weather data, pollution data, and the UV data. So let's click on validate and parse input. And we need to provide the API key and the location. So let's go to open weather map and I'll provide my API keys. Copy it, provide the API key. And for the location, I don't want to provide the location here because it will be hard coded in the code. What I want to do is in the inputs, let's write it location, it'll be string, and I want to provide it here. So I'm based out of Melbourne, so I'll just write it as Melbourne. And here I'll use the inputs.location. Now whatever the output is, it should come as an output of weather API output. So that will be in, and instead of the joke, we can write it as output or response. So let's save it and try to run this. Actually, it's looking a bit weird. So let's fix this. And here you go. You have to provide the location in the inputs, and that location will be used by the Python code where it will fetch the latest information from the open weather API and then provide us the output. So let's run it. So the Python code is running and it's pulling out the API, and soon it should be successful. And perfect, it's completed successfully. Let's click on the output and it is providing the different location, which is the Melbourne latitude and longitude. As you can see, the different components, how much carbon monoxide, nitrogen oxide, PM 2.5, which is the pollution level, and UV index. but this is in the form of the JSON, and this is not a human readable information. So let's do one thing. Let's create a LLM, which we have already deployed. So I'll use that as weather LLM and add. Let's create a connection. We have already a connection created. Chat it is. The deployment type will be GPT-4 mini, and the response format we wanted in text. So the system messages, you are a helpful assistant. You will provide response based only on the information provided to you. Response should be in long sentence and in paragraph format, and keep response concise. Provide a concise output. And then in the user, we have to provide the information. So instead of the question, it will be information. So let's click on validate and pass input. And this input will be the output of the weather API. So the output which we got from the weather API, that output we are providing into our LLM and getting a concise output. And in the output section, previously the output was the weather output, but now it should be LLM output. So let's save it. First, we are providing the location. It goes to the weather API. Then the weather API provides the JSON information to the weather LLM. And then the output will be provided. So let's run it. The run has completed now, and let's click on the output. In Melbourne, the weather conditions, it's providing its clear sky. The temperature is around this. And then it's providing the humidity level and PM 2.5 levels and UV index. Now the response is too long, as you can see, because the information which we fed into this LLM was too long. But I want a certain information, the temperature, the UV index and PM 2.5, which is for the pollution. And let's get that information only. Let's go to our LLM and provide in the system message or the user information, provide a concise output containing only temperature, UV index and PM 2.5 value. So let's validate and pass input because we have made change in the prompt. Validation is successful. Let's save it and let's run it again. Run is complete now. Let's click on the output. And perfect. The temperature in Melbourne is currently 7.48 degrees Celsius. The UV index is 3.6 and the PM 2.5 value is noted as 3.46 milligram per meter cube. I don't know, it's milligram or microgram. I don't know what we call it as, but and this is a very concise output which we wanted. You can have a detailed output. You can have in the form of bullet points. It all depends on the prompt you are writing, and your LLM will create a response according to that. But in this case, we are not using the intelligence of the LLM because we are not getting any information from the LLM. So we are using the external API to get that data and then training our LLM based on that data and getting the information out of it. So the next step here is to deploy. And in the case of the deploy, you deploy it into the virtual machine where an endpoint will be created, and that endpoint can be used in the different chatbots or the different application or web application. I have multiple videos created on creating the chat application or the web application. So I'll provide the link of those videos in the description of this video, which you can see. So I'm not going to deploy this, but this is how you can deploy it and use it in your chatbot or use it in your web application, where you will just provide the location and you will get the temperature, UV index and the pollution level, which is PM 2.5. So that's all I wanted to show in this video. I hope you liked it. Please like and subscribe. Thank you so much.